Good morning, grade 8. How are you doing? I hope you are fine. Today we have a new lesson, chapter 10, lesson 5 in Algebra 1, experimental probability. So, all of you, please open your books on page 727. Our lesson is called experimental probability. Our objectives is to determine the experimental probability of an event and to use experimental probability to make predictions. We have many vocabulary that we're going to learn this lesson. Okay, so we will start by an experiment is an activity involving chance. Each repetition or observation of an experiment is a trial. So again, an experiment is an activity. An experiment is an activity involving chance. Each repetition or observation of an experiment is a trial. So each repetition or observation of an experiment is a trial. And each possible result is an outcome. So each time I am making an experiment or observation, it is called trial. And each possible result is an outcome. The sample space of an experiment is the set of all possible outcomes. Let's read again because we have many new words here. An experiment is an activity involving chance. Involving chance, which means rolling a number cube, like tossing a coin. The observation or the outcome is by chance. I don't have a certain outcome that I know 100%. That's why it is called involving chance. I don't know 100% what will be my outcome. That's why it is called chance. Each repetition or observation of an experiment is a trial. Sorry. And each possible result is an outcome. The sample space of an experiment is the set of all possible outcomes. Okay, I have here three kinds of experiment, like rolling a number cube. Rolling a number cube. Rolling a number cube, the cube has 6 sides. So each side has a number. So when I roll a number cube, the sample space, which is the set of all possible outcomes, it will be numbers from 1 to 6. When I roll a number cube, the sample space, which is the set of all possible outcomes that I will have, will be numbers from 1 to 6, because the cube has 6 sides, 6 faces, and each face has a number. So I have numbers from 1 to 6, so all the set of possible outcomes that I have will be numbers from 1 to 6. Okay, I have another experiment. Tossing a coin. Tossing a coin. Coin, okay? I have 2 faces for a coin. A head and tail. Any coin has 2 faces, head and tail. So when I toss a coin, the sample space that I have, the set of possible outcomes is 2, heads or tails. I do not have any other possible outcomes. It will be head or tail. Spinning a game spinner. Spinning a game spinner. As I see here, I have only 4 colors. So when I spin a game spinner, I have only 4 possible outcomes. Yellow, green, blue, and red. I don't have any other possible outcomes. So, for example, Identifying sample spaces and outcomes. I want to know the sample space, all the possible outcomes that I have, and the outcome. The outcome is the final result that I got. So, tossing two coins. So, the sample space that I will get. If I toss two coins, the first outcome that I can get from the two coins together, two coins together, that I will get head and head, or head and tail, or tail and head, or tail and tail. If I have two coins and I will toss the two coins, what are the four possible outcomes that I can get? And why they are four? They are four because each coin has two possible outcomes, head and tail. So the first one can be head and tail, and the second one can be head and tail. So the first one can be head, and the second one can be head. The first one can be head, and the second one can be tail. The first one can be tail, and the second one can be head. The first one can be tail, and the second one can be also tail. How I write it? I can write it like this one. I can write it like this. H, comma, H, T, comma, T, H, comma, T, T, comma. All of them between brackets. So what is the outcome? The outcome is what here? What is in front of me here? What is in front of me here? I have tail, I have head, and I have tail. So the outcome that is shown in front of me here is head and tail. So the outcome shown, heads and tails, H and T. Okay, B, spinning a game spinner. If I will spin a game spinner, I have only one. So all the possible outcomes that I can get, which is the sample space, I will open the brackets and I will write yellow, green, blue, red, or yellow, red, blue, green, whatever the order. What is the outcome shown here? The outcome shown is green, because the spinner here is on the green. The pointer here is on, not on the red, this one. The one that has vertex, not the round one, the one that has vertex is on the green. So the outcome shown is green. So there is a difference between the sample space and the outcome shown. The sample space is all the possible outcomes that I can get. And the outcome shown is the outcome that is shown in front of me. Okay, girls, let's watch together here a video.
In order to find out the likelihood of a particular event to unfold in the future, we have to first study all the possible outcomes that could happen. This is known as a sample space. Let's take a look at some examples where you can see how we can actually find the sample space for various sort of very simple events and then see where that leads us. So if you take, for example, a familiar number cube, you can imagine rolling it and seeing what number you get, 4, 3, and so forth. Well, what would be the sample space of rolling a number cube? Well, it would be the list of all possible outcomes. So that means that it would include 1, 2, 3, 4, 5, and 6. So in fact, the sample space would be precisely this set, the set consisting of 1, 2, 3, 4, 5, 6. That's the sample space for rolling a number cube. Now, what if you actually were to roll a number cube? Well, you know that one of these are going to take place. Let's see what happens. And it would be a 3. So for this particular example, we see an outcome of 3. We didn't know which outcome would occur, but we knew it would be one of these, and now we know it's actually 3. All right, let's take a look at another example. let's suppose that we take this particular spinner and we spin it twice. Now you can see that half of the spinner is red and half of the spinner is yellow. So what are the possibilities if you were to spin this twice? Well, if you were to spin it twice, let's think about it. Well, what can we see for the first spin? There are two possibilities. We could either land red or yellow. So for the first spin, we could have a red or we could have a yellow. What about the second spin? Well, the second spin could either be a red or a yellow as well. But of course, the second spin could be a yellow, whether it's red or yellow to begin with. So in fact, for each of these, we have two possibilities. We could have a red for the second spin, or we could have a yellow for the second spin. So what's the total sample space, the total complete collection of possibilities? They would include, red, red as one possibility, red, yellow for another possibility. A different possibility would first to land on yellow and then to land on red, and then finally yellow and yellow. And this collection, in fact, represents the sample space. One of these four scenarios will definitely happen if you spin the spinner twice, which was the particular event we're considering. Let's actually do it and see which one of these we get. So I'm going to spin it once. Red. So we know we're in one of these two cases. These cases are out. And red. So in this case, we're red, red. So you can see now that the sample space really captures all the possibilities that could happen of a particular event.
Okay, girls, let's go back to our book. Okay. An event is an outcome or a set of outcomes in an experiment. Probability is the measure of how likely an event is to occur. Probabilities are written as fractions or decimals from 0 to 1, or as percents from 0% to 100%. Again, an event is an outcome or set of outcomes in an experiment. So an event is an outcome or set of outcomes. One outcome or set of outcomes. Probability is the measure of how likely an event is to occur. Probabilities are written as fractions or decimals from 0 to 1, or as percent from 0% to 100%. Okay, here this way of showing the probability is so important. Like 0%, the event is impossible to happen. Impossible to happen. Like we are now learning in our home. It is impossible to go to school, right? It is impossible to go to school, right? So it is 0% to go to school. So events with a probability of 0% never happen. Never happen. So it is called impossible. Impossible or 0%. It will never happen. Opposite to it is certain. Opposite to it is certain. Okay, girl? Certain, which is 100%. Events with a probability of 100% always happen. That now, like what we're doing now, certain. We are learning from our home. Certain, 100%. Events with a probability of 100% always happen. So, opposite to each other, impossible and certain. Impossible is 0%, certain is 100%. In the middle, events with a probability of 50% have the same chance of happening as not. Have the same chance. 50-50. As I told you, for example, have you studied for the test? 50-50. I feel like it is 50-50. I studied for the test. Okay, so events with a probability of 50% have, have the same chance of happening as not. Unlikely and likely. Likely is going to the certain, but it is not certain. It is from 50% to 100%. It is going to the certain. And 50% it is going to the 0%. It is going to the impossible. So now I have 5. I have impossible and I have certain. Impossible is 0%, certain is 100%. Sure, it will happen, sure, it will not happen for the impossible. 50% is in the middle. Likely is going to the certain. Unlikely is going to the impossible. Okay, girls, let's go to the second page. Estimating the likelihood of an event. Likelihood. What is likelihood? Likelihood means it is impossible, it is certain, it is likely, it is unlikely, it is 50%. This is called likelihood. Okay? So there are 31 days in August. If you can open the calendars in your mobiles now, I'm opening it now. Okay, let me open one now in Google. August month calendar. August is always 31 days. 31 here, 31 here, 31, 31, 31. August is always 31 days. Okay, so it will never be a year 30 and a year 31 like February. February, it is always 28, except after 4 years, it is 29. Okay, so August is always 31. So what is the likelihood that there are 31 days in August? It is certain. August always has 31 days, so this event is certain. Carlos correctly guess a number between 1 and 1,000. Carlos must pick one outcome out of 1,000 possible outcomes. So this event is unlikely. Unlikely. Why it's unlikely? Because Carlos is a student that is going to pick a number from 1 to 1,000. He wants to pick the correct number from 1 to 1,000. For example, if I say, Carlos, you will be lucky if you're going to pick 50. You are lucky, Carlos, if you're going to pick 50. 50 is a number from 1 to 1,000. But how lucky he will be if he really will pick 50. He can pick 50, but it is unlikely because it is a number from 1 to 1,000. They are 1,000 numbers from 1 to 1,000. If I tell him, Carlos, pick 50, he will be so lucky if he will pick really 50. So it is unlikely. Unlikely means it may happen, but it goes to impossible. But it may happen, but it goes most probably to impossible. But it may happen. In this case, it is called unlikely. It may happen, but it goes more to impossible because I have 1,000 numbers. If I tell you pick 50 from number 50 from 1000 numbers, you are lucky if you're really going to pick it. C. A coin lands heads up. A coin lands heads up. A coin has head and tail. So it has only two choices, head or tail. So if I'm going to toss it, I will get head or I will get tail. So it is 50-50 to get head or to get tail because I have only two choices, head or tail. So if I have two choices, so it is 50-50. So when it is 50-50, I will say what it is as likely as not. As likely as not. When it is 50%, it is called as likely as not. Heads is one of two possible outcomes. Head is one of two possible outcomes. This event is as likely as not because I have only two. So to get head is 1 out of 2. So I have a high chance to get it. Not a high chance, it is one of two chances. So it is 50%. Not a high chance, sorry, it is 50%. So it is as likely as not. Cecilia rolls a 10 on a standard number cube. 10 on a standard number cube. The standard number cube has only numbers from 1 to 6. How she will get 10? So it is impossible to get 10 because the standard number cube has only numbers from 1 to 6. So a standard number cube is numbered 1 through 6. So this event is impossible. Okay? Okay. So you can estimate the probability of an event by performing an experiment. The experimental probability of an event is the ratio of the number of times the event occurs to the number of trials. The more trials performed, the more accurate the estimate is likely to be. This rule is so important, you have to know it. Experimental probability equals number of times the event occurs over the number of trials. Over the number of trials. Again, the experimental probability equals number of times the event occurs over the number of trials. Okay, girls, like in number 3. An experiment consists of spinning a spinner. Use the results in the table to find the experimental probability of each event. The experimental probability is the number of times the event occur over the number of trials. All the trials. Girls, I want to remind you of fractions. What is the rule of fractions? Fraction is part of a whole. The numerator, I write the part, and in the denominator, I write the whole. The same here for the experimental probability. I write up the part and down I write the whole. The numerator, I write the part, and the denominator, I write the whole. So spinner lands on blue. A spinner lands on blue. So what is the experimental probability? Where is blue here? 8. Outcome blue, the frequency is 8. So I'm going to write in the numerator 8. What I'm going to write in the denominator? Number of trials. And as I remind you, the fraction in the denominator, I write all, the whole, all. So I'm going to add all the trials, 7 and 8 and 5. 7 and 8 and 5. So 7 plus 8, 15, 15 plus 5, 20. So 8 out of 20, when I simplify it, it will be 2 out of 5. So now you know, girls, when I say spinner lands on blue, what is the experimental probability? The experimental probability, I write the trials of blue over the trials of all. Trial of blue over the trials of all. B. Spinner doesn't land on green. The spinner doesn't land on green. So it doesn't land on green. So it lands on red and blue. So I will add up in the numerator red and blue, 7 and 8. And in the denominator, I will write all the trials as we used to do, 7 and 8 and 5, which is 20, and the blue and the red are 15, so 15 over 20, when I simplify it, it will be 3 over 4. And this is called the experimental probability. Okay, girls, if you're going to solve here, the next page, use the information in example 3 to find the experimental probability of each event. 3A, spinner lands on red. Okay, girls, I want you to solve it by yourself, and I want you to send me your answers. Come on. I'm waiting for your answers. Spinner lands on red. Okay, red is 7. Yes, who sent me? Yeah. No, not. Where is the 7 out of 20? Yes, excellent, excellent, mice. Yes, excellent, mice. 7 out of 20. So 3A will be 7 out of 20. And 3B, nice also. 3B is spinner doesn't land on red, so it doesn't land on red, so it lands on blue and green. Blue and green together, 8 plus 50 plus 5 is 13. 13 over 20. Yes, excellent, mice. Your answer is correct. So B is 13 over 20. Okay, girls. Girls, second part, which is prediction, I'm going to give it to you tomorrow. Now I'm going to play 2 videos. You are free on time to leave and go for the second session and to watch later the whole session on YouTube. Which means now I'm going to play 2 videos. The 2 videos may last for 5 minutes. So it will exceed the time of the session and you have to go to the other session. So it's you are free when you want to go to the other session to leave the meeting and go to the other session. And later on you can watch the video on YouTube. Okay, girls? Now I'm going to play the second one.
You know, when we think of a probability, we're really thinking of a number that tells how likely something is. The number can be expressed in 2 different ways. We can think about it as a fraction or as a decimal between 0 and 1, where 1 means extremely likely, essentially certain. 1 is actually certain. And 0, as you get closer to 0, things become less and less likely, so more and more unlikely. And at exactly 0.5 or 1/2, we think it's just as likely as not. Another way to express these numbers is to actually think of a percentage. 100% means certainty, 0% means absolutely not going to happen, 50% means 50-50. So if we were to take a look at a line here, where at one end we have 0%, which means the probability of something happening is really 0, means impossible. Probability is 100% means that it's certain, 50% means it's just as likely as not, This area here means it's unlikely that as you move further and further out, it's getting less and less likely. And here, as you move further and further to the right, it's more and more likely. Let's take a look at some events and see if we can figure out where we place these events on this scale of unlikely to likely. Here's the first one. There are 24 hours on Monday. Do you think that's a likely thing or a not so likely thing? Well, it's a pretty likely thing because we know that each day has 24 hours. So in fact, I would say this is 100%. This is certain. Definitely on Monday, there will be 24 hours. So that's something that happens with certainty. What about this one? So I correctly guess a number between 1 and 2,000. So someone's thinking of a number between 1 and 2,000, and I'm supposed to just think about it and randomly guess it. Well, my chances are going to be 1 out of all the 2,000 possibilities. 1 over 2,000 is really, really small. It's a very small percent. I'm going to put that near impossible. Extremely unlikely. Extremely unlikely. Oh, I'm doing something else. So here I'm going to roll a 4 on a standard number cube. So take a standard number cube, and I roll, and the question is, how likely is it it's going to land that way? I'm rolling it at random. See, I got a 3. So that doesn't seem to be too likely. So I'd say it's not too likely, although I wouldn't say it's impossible, but I'd put it that it's sort of a little bit unlikely. A little bit unlikely. Could happen. Certainly not 50-50, but certainly not impossible either. And finally, oh my gosh, look at all these things I'm doing. I'm guessing numbers, I'm rolling number cubes, and now I'm going to roll a 7 on a standard number cube. What do you think? Likely? Unlikely? Well, if you take a look at a standard number cube, the numbers go from 1 all the way to 6. So 7 is not even an option. Therefore, I know for sure that if I roll a standard number cube, the likelihood that I'm going to see 7 is impossible. That's going to be impossible. And so I put it way over here. And so you can see how we can sort of just get a vague sense of where things are in terms of the likelihood of those things. But now what we're going to do is actually put a numerical value to certain of these things, and we can actually say exactly where they are on the spectrum from certain to impossible. We'll see that soon.
Okay, girls, and let's watch this one also.
Okay, to warm up to the sort of abstract idea of probability, we can actually come to it by looking at concrete data, which we've been doing. And we can compute what's called experimental probability. So here's how you actually compute experimental probability. You look at the number of times a particular event occurs, and we divide that, we create a ratio of that over the total number of trials. And we get a sense of an experimental probability. So let's look at an example. Suppose we have a spinner that has 3 colors on it, red, blue, and green. And we spin it a whole bunch of times, and 7 of the times we see red, 4 of the times we see blue, 9 of the times we see green. The question is, what can we conclude about the experimental probability of various scenarios? So the first question I want us to think about is, what is the experimental probability of actually seeing blue? Well, how would we actually compute this? Well, what we do is we take the total number of times that event occurs, blue, that's going to be 4, and we're going to divide it by the total number of trials. Well, how many trials do we have here? Well, we have 4 and 9 is 13, and 7 is 20. So we see a total of 20. So I see 4 divided by 20, which can simplify down to 1/5. 1/5 or 20% probability. Okay, so that is the experimental probability for blue. What about the experimental probability of not seeing green? Not seeing green. Now that's sort of funny because what does that mean? What's the total number of times the event occurs? That means total number of times you don't see green. Well, you could either then see red or blue. So we have to add up those 2 possibilities. So we see 7 plus 4, and we see 11. So we see there are 11 possibilities for when we did not see green out of the total 20. So we see 11 over 20. That's the probability of not seeing green, which is 55%. So you can see it's actually a little bit more likely than not that we'll not see green, but it's actually not so likely that we'll actually see blue. So you get a sense now of how to put a numeric value to a probability just through experimentation and looking at data.
Thank you, girls. We're going to continue the last part tomorrow. See you tomorrow, inshallah. Bye.